All right, guys. So today we are summarizing kind of what constant rate of change is. And notice that the key word here is constant rate of change. So I gave you this beautiful little handout. When we're done, you can just do an accordion fold in it on it. And it just kind of, hopefully, you can easily put it somewhere, keep it stored, or glue it in your notebook. That's why it says glue this side in your notebook, okay? So we're going to start here in the first column. I know we're going backwards, but we're going to start in the first column. So if you look in the first column, we are defining constant rate of change, okay? A constant rate of change is what we call slope. Does that make sense? So hopefully that was a takeaway for the Desmos, that a constant rate of change is what we refer to as our slope of our linear equation, okay? The slope is your m, okay? M equals your constant rate of change. Your b in the equation, y equals mx plus b, is where the graph crosses the y-axis, right? Do we agree? And then lastly, to find your slope from a graph, if you can, you just do rise over run, okay? Some teachers may also call it fall over crawl. You also can go down and then go, right? So you can fall and crawl. To find the slope from a table, we would be using y2 minus y1 over x2 minus x1. Does all this ring some bells? All right, so we're going to start with the graph here. So if you look at our graphs, it says examples of positive constant rate of change. So we know that it is positive because as we read the graph from left to right, what is it doing? It's going up, it's increasing, right? So from a graph, I have two clear points that I can use to help me find the slope. And finding the slope in this case would be a rise, 1, 2, 3, 4. I rise 4 and I run 1. So my slope equals 4 over 1, which equals 4. So the constant rate of change here is a positive 4. Make sense? Okay. I would like for you to take a moment and do the same thing on this graph. Okay. Identify two key points and find the constant rate of change, the slope. All right, let's see where we did. So I'm going to identify two key points. So for me, it looks like I saw the y-intercept here and a point down here. So I'm going to rise. And how much do I rise? 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to run 1, 2, 3. So therefore the slope equals 8 over 3. And we want to keep it as a simplified fraction. Is that simplified? Yes, it is. So it's a positive slope of 8 over 3. Okay. When you look at these two positive slopes, you can see that the one, our first example, it had a slope of 4. So it's a little steeper than the one with the slope of 8 over 3. The bigger the slope, the closer it looks to becoming a vertical line. Does that make sense? Yes. Oh, yeah. Okay. All right. So here are our negative slopes. And the reason why they're negative is because as we read from left to right, what are the lines doing? Going down. So let's do the first one together. So I've identified 2 points for you, the ones we're going to be using here. Remember I said sometimes you may fall, then crawl. So this is an example of falling and then crawling. So I'm going to fall 1, 2, 3, 4, 5. And then I'm going to crawl 1, 2, 3, 4. So the slope here equals, exactly, it's a -5 because I had to fall. Does that make sense? So it's -5 over 4. All right, so I'm going to quickly give you guys a chance to do the one on the bottom. Let's talk about it. So this time the points were given to you. Doo-doo-doo. Doo-doo-doo. And again, I'm going to fall 1, 2. And since I fell, that's a negative. I'm going to the right 2. So my slope here is. There we go. My slope here is -2. It lets me, right? -2/2, which equals -1. Okay. All right. Okay. All right. So here we're talking about the constant rate of change again. And as we understand, rise over run, just summarize what we did. The rise is your vertical change and the run is your horizontal change. Okay. When we are emphasizing rise over run, notice how when we went down, what did that number become? Negative. Okay. So keeping that in mind, if you're going down or to the left, that counts as a negative. If you're going up and to the right, those counts as positives. So as long as you remember that, then you should be good as far as calculating slope. So if we look right here, we have another line, and quickly looking at this line, at this point, could we just count out in our heads and figure out and be good with it? So really quick as a class, what is the slope here? What is it? 1/2. 1/2. Good job. Okay. Looking at this one. +4/3. That's a weird 3. Okay. How do we feel? Now one's like, I've never seen any of this before. Cool. Now we're going to talk about, well, what if you don't have a table graph? Well, that's okay. That's what the formula is for, right? So if I don't have a graph, then I just use the formula. And the formula is, if given 2 points, I plug them in, I find the difference of the y's, difference of the x's, and I divide. So when we say this is change in y over change in x, okay? The triangle is called a delta. So delta y over delta x. All right. So we're going to do number 1 together, and then I'm going to have you do 2 and 3. You should in science, delta. Okay. So here, this is my x1. Here's my y1. Here's my x2. Here's my y2. So I'm plugging them into the slope formula. So m equals -4 minus 2 over -3 minus -6. Okay. So here we have a negative times a negative makes a positive. So you owe me $4. You're like, hey, let me borrow another $2. You now owe me $6. You owe me $3 and you have $6. What are you left with when you pay me? 3. So what is the slope here? The slope is -2. Huh? All right. All right. So I'm going to pause, stop talking, give you a couple minutes to do 2 and 3 really quick and check with your peers, okay? Before we go over it. All right, let's see what we got. So for number 2, what'd you get?
0.
Okay.
2. Negative 2.
Whoa, why am I getting all these different answers?
Oh, wait, no, that's. Oh, yeah.
Oh. Okay, so we had 12 minus 8 over 9 minus 1.
Oh, wait.
X is on the bottom. 12 minus 8 is 9 minus 1. So your slope is 1/2. Okay. No. Changing delta y over delta x. Okay. All right. On number 3, what do we get?
Negative 1 over 4.
Okay. So we got negative 2 minus negative 3 over negative 1 minus 3. A negative times a negative is a positive. So that means we have positive 1 over negative 4. And so our slope is negative 1/4. Okay. All right. Today's meant to be an easy, easy breezy day. Okay. On this next column, I want you to go through and identify the slope and the y-intercept from the problem. Okay. Your y-intercept, I want you to write it as an ordered pair. So ordered pair means it's 0, comma, the b value. So I'm going to give you, is it 90 seconds? Is that fair? To go through and identify the slope and y-intercept? I think that's fair.
All of them or just
For all 3 of them. All right, let's quickly over it. So on the first one, identifying slope and y-intercept. So your slope clearly is -8. Your y-intercept is 0, comma, -7. On number 2, your slope is 4/9. Your y-intercept is 0, comma, 3. And here, number 3, what is your slope? -1. And what is your y-intercept? 0 at the origin. Okay, that's what you were supposed to be doing in 90 seconds. All right.
I thought we were doing like some sort of thing and I just forgot it completely.
No, it just says identify. All right, last but not least, the last format of finding constant rate of change, aka slope, is from a table. So when you're looking at a table, you are comparing the change in the y's or the change in x. So how did I go from 4 to 8?
7.
Plus 4. How did I go from 3 to 6? Plus 3, right? I go from 8 to 12. Plus 4. How did I go from 6 to 9? Plus 3. How did I go from 12 to 16? Plus 4. And we see what's happening. So what's the slope of this table? M equals 4/3. All right, I'm gonna give you 30 seconds to do this one. And then we're done. All right, so quickly going over, what did we get here? We got 2/1 because you can see from here to here, the change in the y is 2, the change in the x is 1, and that pattern stays all the way through. So m equals 2/1. Okay, what I want to reiterate, even if you did from here to here, you would have 8/4. And what was 8/4 reduced to? 2/1. So no matter what, the slope would be 2. It's constant. Okay. All right. So what you're doing, hopefully this Algebra 1 refresher, refresh some thoughts, open some file cabinets, dusted off some cobwebs in your brain. On your canvas, ignore that. On your canvas for today, we took the notes, and as you can see right here, it says that you have a 1.28 rate of change assignment. So this is our rate of change assignment. So you're using your previous knowledge and your notes. So you're going to go through and answer these problems about rate of change, constant rate of change at that. And there's 8 questions. If you're not happy with your grade, it says that you have 3 attempts to correct it. Okay. Are there any questions, comments, or concerns? All right, that is Algebra 1 refresh for you. Trying to fill in those gaps from remote learning year or COVID year, depending on when you took it.